Happy Chinese New Year.
Okay. Diamond, I'm going to teach you computer number system today. Okay? So computer, we know normally what digits are we using?
Decimal.
Decimal. Okay?
1 to 10. I mean 1 to 9, and then you.
No, it's 0 to 9.
Oh.
You forgot 0.
Oh.
But computer, it's using what?
Binary.
Yeah, binary.
So 0 and 1.
0 and 1. Do you know why?
And 0. No.
Okay, it's because computer. It's in electricity. It's using electricity. It's electronic device, and the power on
It's 0.
normally is 1.
Uh,
Power off, it's 0. For example, let's take a look. You see the light, right?
this is 1.
It's 1, yes. I turn the light off. It's 0. Okay? This is one way. The other way is, the electronic voltage.
So 1 is high and 0 is
Yeah.
no.
Voltage, yeah. High is 1, low is 0. Okay, cool. Where's the eraser? Eraser, I need the eraser. Okay.
And now difficulty.
Let me ask you a question, okay? So, for binary.
Okay.
Okay? So, what is a decimal number 1 in binary?
1, so there's 0 and 1, so it's just 1.
1, okay? What is decimal 2?
You need to run the output place. I learned that before, so you put 1 0.
1, 0, okay, cool. What is 3?
1 1.
1, 1, good. What is 4?
1 0 0.
1, 0, 0, okay, yes. But that's the problem, you see. The problem is, for example, if we are trying to describe a decimal number, maybe it's quite small, but in binary it might be really large. See, for example, let's say
12.
12. Can you write down how it is written in binary? Give it a try. Yeah. I told you how to transfer a decimal number into binary, like
Oh, yeah.
12 divided by 2.
Oh, 0.
Okay.
There will be 6. 2. It will be 0. It will be 3. And then divided by 2. It has a remainder of 1, and then it will become 1.
Mm-hmm.
And divided by 2, it has a remainder of 1.
1?
What? Oh.
What's 1?
2. What?
2 is greater than 1. Why is 1?
Because there's 1 left.
Oh, yeah. Well, left 1. Okay, yes. So what's the number?
If you read it backwards, so it's 1 1 0 0.
Okay. Nice. Okay. So, for example, what is these 3?
This 3. This is
Only these three.
Let's say this is 4.
Yeah, it's 4, right? 4. Okay. What is this one?
This is 8.
8. Yes. 8 plus 4 equals to 12, right?
Yes.
So you see here in decimal 12 we only occupies 2 digits, right?
Yes.
2 digits place. But for binary, the length is 4. 1, 2, 3, 4, right?
Yes.
Okay, so here's the problem. So it's for computer. Binary is easy for computer to understand.
That's hard for
But
us.
for human beings, it's sometimes it's really hard to write to demonstrate maybe a small number in binary. For example, if I write
What is that? Looks
can you read what is this number in decimal? No, I can't either. Okay,
It
so
looks like
that is a
billion.
so there are 2 other ways. One way is one way is for example for the binary, let's say for example the numbers we wrote just now. One way is we group each 3 digits together, as a base, which is based upon 8. The other way is we group each 4 digits. This is 3 digits. This is 4 digits. You see?
Yeah.
4 digits. This is base 16. This one is called octal. This one is hexadecimal. This is based upon 16. This one is based upon 8. So let's for example, let's say this one. Okay, here is the question for octal numbers, because you see it's every three binary bits. So what are the base numbers for this octal?
0 to 8.
No.
0 to 7.
Yes. Okay. So what's the base for the hexadecimal?
0 to 15.
Yeah, 15. Good.
But,
Okay.
But 15 is 2 digits.
Yeah. So we for this one, in fact it's 0, 1, 2, 3, 4 to 9. Then
A. B.
capital A, B, C, D, E, and F.
That's
Okay.
yeah.
So what does this mean? This means A means 10. This B means 11. C means 12.
So this
Can you finish the rest?
13, 14, 15.
Okay. Yeah.
And this is
Okay. So that's good. Okay. So why we are using this way? Why we are using like a octal and
what?
hexadecimal? Is because its base. This base is 2. This base is 10. This base is 8, and this base is 16.
Why are they useful? You only need 10, right? You only
Human beings, we use 10, based upon 10. But sometimes in computer science, sometimes we use octal, sometimes we use hexadecimal. For a very good example for hexadecimal is color system.
Color.
Yeah, color. I can introduce the example about the color.
What about light blue? This one.
Mm. Okay. Let me tell you. Tell you something. In computer science, we have three basic colors.
Blue,
It's red,
green,
green,
yellow,
and blue.
blue. Wait, so this
Okay.
color is
So
like
for
blue.
example, for the red color,
It's
normally
zero?
we use a pound sign. It's
Zero?
F 0 0 0 0. It's red. Okay.
So,
This is red.
wait, so F is
And for the green, it's 0 0 F 0 0. For the blue, it's 0 0 0 0 F. What does this mean? Okay, so
wait, it's I think red is bigger. The number is bigger than green, and green the
it's
number
bigger than blue. Yes.
Because this is F and then the front.
Yes.
What is it? What is F mean again?
F is 15. You forgot that?
50? Oh. Oh yeah, the
You
last
see?
one.
Okay, so
50.
let me ask you a question. So for don't write anything for now. For each digits, for how many digits we have here?
You have
4 color for one color. 1, 2, 3, 4, 5, 6, right?
yes.
And for each this digit, how many choices do we have?
And this is 15, 16.
16. You always forgot the zeros. So this is 16, right? This is 16 choice,
Yes.
right? And so this is also 16, 16, 16, 16. So while this way, with the pound hash, along with the hexadecimal presentation, or no, description, how many ways, how many colors can we present here?
16 power 6. No, 16 power 6.
6 power to 6. It's
Oh yeah.
16 power to 6, right?
Yeah.
Right?
Wait, what is the pound sign used for?
Pound sign means it's hexadecimal.
Oh.
If in future, if we see a color, so what does this mean exactly? Why is FF? Okay, FF means it's very red. If it's like the first two means okay, it's
Wait. So the
how much red it is.
oh so
You
this
see,
this has some red and this has less red and this has the least red.
no, it's this is the red colors, the most red color, okay? But this one is 0, not red at all, and
Why?
not blue at all.
Oh.
You see, this one is most red, not green at all, and not blue at all.
Wait.
You see what you see? You see what I mean?
Yes. So it's like there's an imaginary box and this side is red and this side is
Green.
and
And this is the blue. Yes.
And then this is like the pointer of it, right?
Yes. Exactly. Yes. Yes. Okay. This is how we use hexadecimal. Okay.
So pound sign means hexadecimal.
Yes. Okay.
What about
Let me give you a
octo? What about octo?
octo. I know navigation. You know navigation?
No.
Navigation.
No, I've
you know,
done
people-
every
They
GPS.
something like that. Something like that. It's that is a device. It's basically,
Yay. How?
you see here. Look at this.
Is it?
You know this is east, right? This is west. This is north. This is south, right?
Yeah.
So you see the directions has these lines separate all the directions into eight directions.
Wait, but
You see, this is for example, what is this? This is northeast. This is southeast. This is west east, west south, and this is west north. You see?
Wait.
So hexagonal basically can be used to on the ocean. When the ship is navigating on the ocean, and it's using some device which is using the octal this octal one. It's for example every 8, because the base is 8. So for example, let me ask you a question. In octal 7 plus 1, what are you going to what is 8? Why there is 8?
So 1 0.
Yes, 1 0. Yes, because it's based upon 8, and so 8 doesn't exist in 1 digit in octal presentation. So when you 7 plus 1, you have to carry 1 and 0 1.
This very confusing me because this looks like 10, but that's
It's yes. Okay. Nice, very nice. Okay, let me ask you a question. So let's say if I'm writing a number 10, how do we know it's decimal, it's a binary, it's octal, or it's hexadecimal? There is a way.
-1.
No. We write a tiny base here. For example, if I wrote a 2 here,
This is binary.
this means binary. Yes.
This is
If I
0.
write 10 here, it's decimal.
So this
If I
is
write
10.
8 here, it's octal. And if I write 16 here, it's hexadecimal. Okay?
No, you need a pound sign.
You can do this as well. But if you are not using pound sign, you can do this way. A very tiny number here, base here.
Wait, so there's a pound sign for hexadecimal. Is there something for octal?
I don't know.
Oh.
Maybe that is, but I don't know. Okay, let me give you a question. So, one zero zero zero. Okay, 2.
This is
What is this in octal?
octal.
And what is this in decimal? And what is this in hexadecimal?
I want to turn this into like decimal first because I'm used to
Okay,
that.
yeah, do give it a try.
So I learned that there are 3 zeros. So it's 2 power of 3.
Okay, so what's that?
16.
No.
8.
Mm-hmm.
So and wait, this is backwards.
No, it's equal. It's equals.
What?
You for example, you should write 8 here, right?
Oh, wait.
Okay, that's it.
Oh,
Because decimal 1000 equals to decimal 8.
oh.
Okay,
So-
what's the
But I know. Wait. So 8 does not exist in the octal. So one more than you need to like have
Carry on.
Yes, carry the 1. That is 1 0.
Yeah, you wait a second. You should write this a little bigger, or people will say, okay, it's 108, which is wrong. Okay?
1
No,
0.
too big. Okay, it's okay.
1 0.
Okay.
And 16. Wait, there is a number for it. Wait, it's still 8. It's the same thing.
Okay.
Because there is a 8 and 16.
Okay. Yeah.
Give me a number like 11 or something. That's not in 10.
This is a good way because you are familiar with the decimal. So you turn this one into this one, then turn this one into this one, and turn this one into this one, right?
Wait,
So I know it's a good way, but that's a bad way. As I told you, that you can always for just I told you why we import octal and hexadecimal word. It was because while octal and hexadecimal, it's easier for us to present the numbers, which computer is easy to understand about human beings, how to understand in binary. So we can group, for example, this one.
Dad, I just realized that all of them are divisible by 2.
Yes. We can group these 3, the group. This one is another one. Let me take.
Wait, so you group 3 because this number power of 2 is 8 or something, and you group 4 because this number power of 4 equals to 16 or something, right?
Yes.
Wait, so what is 2 power 2? Is it, wait, 2 power 3, is it 8?
It's a 2 power 3 is 8.
2 power 4 is 16?
Yes.
So
That's one more.
Wait, 2 power, oh. Wait.
I think this is wrong. We should throw the least significant. You see, like
Okay, so how many zeros, right? Like
this one. What is this one?
this is
This is
wait, what
okay.
is that? Is that
0.
Oh, I thought that was
Okay.
2.
So this is 0, right? Right? This is exactly 0.
Yes.
Right? What it is?
This
This means, so this means 0 times 8 zeros. This means 1 times 8 to the power 1. So this one is
0.
it's 0, right? So
Because
this one is 8, right? So
Yes.
it is 8.
So
it is 8.
I
Right?
remember that you told me this is
But
so
wait a second. When we are talking about this, through this way, we are parsing this guy to decimal. But how to parse it to octal? We group these 3 numbers, and this is 0, right? These 3 numbers in octal is 0, right?
There is
This
0.
one is 1, so it's 1 0. It's 1 0.
What? Yeah.
What does this mean? Okay, this 0 in octal means 0 times 8 0. 8 to the power of 0.
And
This guy is 1, right?
so this is
This one means
1
times 8
1.
to the power 1. Yes. So,
Yay.
okay, so let me give you a question.
I still do not understand because this seems confusing.
Now let me give you. Oh no, that's no 2.
2
Okay.
does not exist.
Also my 2.
2 does not exist.
I want to turn this one directly into the octal presentation. Yeah, how to do this?
Because you group 3 on the
Oh,
least.
Yeah, these 3,
Yes.
then these 3, then this one. Okay, so what do you get?
There are 2 ones.
Calculate by yourself.
And this is 5.
Yes, 5.
8 power 2.
Why 8 power 2?
And I don't know.
This is the last one. It's 0.
What?
You don't care about how many. Okay, so what's this one?
This one is this one is 6.
Okay, what's this one?
1.
So yeah, so it's 165. 165 in total.
So you just count how many this?
Yes, exactly, yes.
Oh.
Why? Let me explain it. Because this one, hey, what did you do? It's here. Why did you erase it?
I don't know.
Because here, listen. This means I grouped the 3 digits, the lower 3 digits.
Alright.
This means these 3 means these are based upon 8 to the power of 0. These 3 is based upon 8 to the power of 1. And this one, it means
8.
1 to the 8 to the power of 2.
Wait, so this is
So if you want to calculate into
hexadecimal.
decimal, no, just decimal.
Oh.
Well, what did you get? It's you just calculate this one. 8 squared, 64
Okay.
plus
Uh,
48 plus 5, because this one is 1, right? So you can get the decimal number, all right?
right.
This is because here we are using decimal to present.
How is this 48
6 times 8.
and 48? What about the 1 here?
1 is here. 1 times of.
Oh, I thought this was just. I thought it was 16.
No. You got it?
Yes.
Okay. So now how to turn this one into. Okay, you can calculate this one. Do this job and fill in the correct number here.
Wait, this one?
This plus this one plus this one.
This is. 64, 48, 5, 7, 11. That's 100 and this.
Yes. Okay. So here's the question. What's the hexadecimal of this number? You.
Wait, so I heard that you said you turn it into 4. You group it by 4.
Yeah, group by 4. Okay, well, how to do it?
So this.
Yeah, this one. Okay.
And then this one.
Okay. Yeah, good job. Yeah, do it now.
This is a 5 power of 0, so this is just 5, and this is a 7. No, yes. So 7
Yes. So what it is?
multiplied by.
You don't need to write anything
Right.
here. So the answer is 75. 75.
And this
Because this one means 5 multiplied by 16 based to the power of 0. This is 7 times of 16 power 1.
Look, 16 power 1 is 16, so 7 multiplied by 16.
But you got it, right?
But
What's your
you
question?
don't multiply by 16 here.
It is 16. This one, these 4 digits is based upon 16 to the power of 0. These 4 digits, in fact, that's a 0, but you can ignore it.
4 zeros.
Yeah, because it's these 4 digits based upon the base of 16 to the power of 1.
But 7 multiplied by 16 is power of 1.
You can calculate.
Okay. $112.
But you need to also add them plus this 5, right?
Yes.
What's it?
Oh, so this is decimal? Oh.
You know it?
This is decimal.
Yes.
But,
This is a calculated decimal, right?
oh, so you just count how many, you just find out what number is this and find out what this number is and you put in hexadecimal and then you can
Yes.
do stuff to turn this into decimal.
Yes. Okay. Now you understand it, right?
Yes.
Okay. Now let me give you a question. You need to figure it out by yourself, okay? The 1 0 0 1 0 1 0 1 1 0. What it is in octal and what it is in hexadecimal. Okay. You need to calculate by yourself. Oh, wait a second. And the last thing. Okay. Just do this first.
Okay. This is 6 and 6 and this is 2 times
What do you care about what is based upon? I'm not asking you to turn it into decimal.
so 2 and this is 1 and this is 1. So this 1 1 2 6.
Don't look at me. Do your job, okay?
This thing wait, you told
Yes.
Oh.
Okay, now how to make it? Yeah.
Wait,
Hexadecimal.
Wait, I finally know. So you just count how many is there. This is 6. This is 2 and this is 2. So this is 2 2 6.
No, it's wrong.
Wait, this is 6 and this is 2 and this is 2.
What is the second one?
This one.
What are you writing?
2.
What are you writing? Do it again. Erase it. Do it again. No. The whole number. You divided it wrong.
Oh, this is 6.
This part is wrong. This part is wrong.
Oh! Four of them. Ow. This is 6. This is 5. This is 2. This 2, 5, 6.
This time you are correct. Yes. Okay. Okay. Calculate decimal.
Decimal. This thing multiplied. Oh. What do it do? This thing this thing is just 6. This thing multiplied by 1. Wait, no. This thing is just this thing, I think. And this thing multiplied by 2. This is 4. So it's 456.
You don't look at me. Try the above one and try to transfer the above octal number into decimal and then check whether they are exactly the same. Okay?
How do I transfer octal? This is just 6, and this is just 2. I think. This is
What is 2?
This is 2.
Yeah, what two does this mean?
This means this.
Yes, what does this mean? What's its base?
This is based on binary.
I'm not asking binary. I'm asking, can this one?
Oh,
This is octal, right?
yes.
We turn this one into decimal.
But
So what you wrote it here is 6, right? Why? Why is 6? Because it's 6 multiplied by a to the 0.
Oh, yeah. Now I know. So this is 2 multiplied by 8 to the 1, and that's 16.
Yes.
And this is 6,
Yes.
and this is 1 multiplied by 8 power of 2, and that is 64.
Yeah. Okay.
And this is 1 multiplied by 8 power of 3, and that is 64 multiplied by 8. Okay. This is 2.
Yes.
512.
Yeah.
So this is
You need to plus all of them,
100.
right?
Yes. And this is 18, and this is 598.
Is this one equals to this one?
No.
So you must make something wrong here.
Yes. So this is a 5 multiplied by 12. Anyway, 16 power 0, and that is 5. This is 5 multiplied. No, this is 6. This is 5 multiplied by 6 in power 1. 5 times 100. This is 80.
80?
Right?
What's 80?
Let me think. Divide 5 is 30. Yeah.
Yeah, it's 80.
Yes.
Okay. Okay,
And
this one?
This one is 2 multiplied by 16 power of
2.
2.
Yes.
And 16 power of 2 is.
You need to calculate it.
Wait, no, it's 16 multiplied by 16. 16 squared is. Oh, this addition stuff. Right. Yeah. 256, and I need to multiply
No,
that
not
by-
you need to.
by 2.
Okay, yes.
560.
This is wrong, right?
This is. Oh, yes. This is 2, and this is 5.
Okay.
And 512 plus 80 plus 6 is 895.
Are they equal?
Yes, they are.
Okay.
So this is 508, and this is 10.
Yes. Okay, good job.
Yay. I
Okay,
understand.
so now you understand it.
Yes.
Okay, very nice. All right. Today we just learned how to transfer binary to octal, binary to hexadecimal,
And
and
binary.
binary to do decimal, octal to decimal, and hexadecimal to decimal, right?
And we learn to transfer binary to decimal to
Yeah. Oh, the,
I mean, I
Okay.
learned that. I tried to do that.
okay. So that's it. Thank you guys. That's all
Bye.
for today.
Bye.
Happy New Year.
Happy Chinese New Year. Yay.